which has gained importance, much more importance these days, especially after the advent of artificial intelligence. Now, if we look at the title of this lecture presentation, there are two terminologies, knowledge and wisdom, but there is another one which is intelligence. Now, unfortunately, what happens that usually these three terminologies are being used quite interchangeably in our society. We generally believe that if a person is knowledgeable, then by default, he will be intelligent and wise as well. But this is not true. All these three terminologies are quite distinct from each other. They are different. They have different regimes. They are different traits of human mind. Although they are well connected with each other, but each of these has its own distinct presence. And if we ignore any one of these, we will not be a successful person or a successful society. So this lecture will intend to differentiate between these three terminologies. In fact, knowledge, intelligence, and wisdom, although intelligence is hidden in the title. And then I will try to expand it to our engineering practice. So first of all, there will be a general discussion on these three terms, and then I'll try to apply to different engineering disciplines, or specifically to civil engineering discipline. So to achieve the objectives, the outline that I will be following for this lecture, we'll start with the differentiation between these three terminologies: knowledge, intelligence, and wisdom. Okay, once we define these terms or explain these terms and get the insight of these terms, we'll see how does wisdom show up, or how does wisdom help us, a person or a society, what benefits we get out of it. Okay, once we determine that thing, then we'll start discussing its importance in engineering practice. Through different examples, I will try to explain it through different examples, and we'll have a deep discussion on that one. After that, there is a big time question. Once we establish the importance of wisdom or intelligence in our engineering practice, in our lives as well, the big time question is how to develop wisdom. Okay, so we'll have like a discussion on that. And finally, I'll have conclusions and some recommendations. And the recommendations will also focus on how we can develop knowledge and wisdom. And then I will end up with, like, as I mentioned earlier, that the artificial intelligence has creeped up in our societies and creeped up in our daily lives as well. So what's the role of artificial intelligence among these three? Where does it stand? Do we need it? Don't we need it? And if we use it, then what should be effect on our society? So there will be a brief discussion at the end of this lecture. So let me start with a discussion on what's knowledge, definitions, very simple definitions I have put forward over there. So what is knowledge? Knowledge is just actually a memorization of discrete data or information. It is just restricted to memorization. We should not go beyond that one. So when we say a person is knowledgeable, it doesn't mean that he has intelligence or wisdom. So what is wisdom? Which is basically the comparison which I'm going to do in this lecture. So wisdom is basically a trait of human mind through which we make sound judgments and decisions using conceptual comprehension of information. Now you see here, there is no memorization over here. So where the memorization went, in fact, there is an intermediate trait, we call it intelligence. Now intelligence, what intelligence is? Intelligence is the conceptual comprehension of memorized data and information. So it is a step in between knowledge and wisdom. We have to acquire knowledge, then we have to understand that knowledge, and then we have to apply that knowledge through wisdom. So that's what is the connection is. So we established in this very first slide that there are three different traits, and each trait comes after each other. This is the first thing. And second is that memorization based knowledge or knowledges will never lead to wisdom in a person or a society. So only a conceptually gained knowledge leads to wisdom. So wisdom is cannot do anything till the time there is a conceptual comprehension of knowledge. So after defining this briefly, and I'll say a comprehensive understanding of that one, we'll get more insight into these three terminologies through some very simple examples. Now I am presenting these three regimes in this manner. What is knowledge? Knowledge is just perception, and all the questions which start with what. Okay, very simple example. When a child grows up, when a human child grows up, he starts asking, what is this? What is that? So when he looks at the chair, he will ask, what is this? So answer is chair. So this is just the knowledge. Okay. And then what is the next step is the intelligence. So as he grows further, he should be asking these questions. Why the chair is there? What is the objective of the chair? What is the purpose, or why there is a seat? Why there is a chair, first of all? Why there is a seat? Why there is a back? Okay, what's the purpose of these legs? Okay, what's the purpose of these braces over there? So this basically, all these questions lead to development of intelligence about the chair. Now, more deeper you go, the higher levels of intelligence we will get. Like, for example, I mean, in our society, generally you don't go beyond that one. I mean, why this chair is there? I mean, what's the purpose of chair? Comfort can be achieved. A person can sit on this chair without having fatigue and without having deterioration of his back or his backbone, because this chair causes the deterioration of the backbones. So through why-based questions, this is basically intelligence. Now, after we get this comprehension, the conceptual comprehension or the intelligence about the chair, we can use it. We can use it using the wisdom we have, the trait of wisdom we have. That is application. Now, if we have gained a deep knowledge about intelligence about the chair, we can apply it in a very nice manner. Like, for example, this chair. I can easily say that all of us, all the listeners, all the participants, respectable participants, they must be sitting on the chairs. Have you ever thought that the chair which you are sitting is giving comfort to you, or is just like looks beautiful? I mean, that's why we are sitting on it. Does it cause a fatigue to you? So all these questions which are required by the user must be known by the manufacturer or the designer of the chair. If we look at this one, we can see here that this chair is basically, this chair is designed differently. You can see there is a specific design of the back, specific design of the seat, and armrests, and then we have wheels or rotating design considering the comprehension. So if we cannot design this one, then even if we design something like this one, we'll be definitely ending up into wrong product. We cannot compete in our markets. Okay, look at this chair. This is even more advanced form of this chair. So why people are putting these different the different elements of this chair? Because they know, they have a knowledge, a conceptual knowledge, what a chair is for. So that's why they have designed like this one. This was another one I'm showing you over here. This chair has been awarded one of the best chairs in the world, one of the best or most comfortable chairs in the world so far. This chair was designed and used in one of the James Bond movie in 1970. 1970s. And since then, this chair has been declared as the most comfortable, one of the most comfortable chairs, because it was designed using the comprehension knowledge and then using the wisdom. So that's what I want to explain, like how knowledge, intelligence, and wisdom differentiate from each other in developing things. So we can easily say that from perception to application, that's what is required. Now, all these traits are hidden within a human brain. And more specifically, we can say that these are hidden within the human mind part of the brain. So that's actually another terminology. Usually we say human brain, but we interchangeably or synonymously we use it another terminology. We say this is like a human mind. But human mind is something highly specific to humans only. This is absent in animals. So this human mind, in fact, involves all these faculties. All these traits are hidden within that mind. Okay, so that's what the capabilities, if you combine these capabilities of human being, we call these as cognitive abilities. Cognitive abilities, and we also name them as core or critical thinking abilities of human mind. Now, basically, again, now we have another two set of definitions coming up over here. One is core thinking skills, another is critical thinking skills. So if you look at here, core thinking skills, basically the understanding of the things, the conceptual understanding of the things. And here in the critical thinking skills, we are evaluating, analyzing, evaluating, and then creating something new. Okay, or creating, we are either creating or innovating over here. So if we combine the core thinking skill abilities, we call it intelligence. And then if we combine critical thinking skills, we call it wisdom. So how these are interlinked within a human brain? We have to see, or a human mind, more specifically, as I mentioned earlier. So we have to look from that point of view. This is a hypothetical sketch of human mind, not human brain, because human brain has a lot of other portions which are controlling our other actions. But the human mind is the part of the brain which is specific to human, and it has all these abilities inherited in it. So if this hypothetical sketch is just there to show a linkage or a coordination among all these faculties. I'll define it further. Like, for example, this part, I'm calling it a knowledge mind. And this one is inquiring mind. This is a conceptual mind. And finally, this is a creative mind. So our human mind can be divided essentially into four parts. We have a knowledge mind, which is basically nothing else but memorization. So this is good for memorization. We gain all our knowledge and we store our knowledge in this part of the mind. We call memorization. But once we memorize something, another part of the brain, which we call inquiring mind, comes into picture and starts asking questions, which I have mentioned before. So this inquiring mind asks all questions about whatever we have memorized, whatever we learn, whatever we memorized, or whatever we just by definition we learn. Our inquiring mind starts asking questions. Now, who will answer this question? We have another mind in part of the mind in our brains, that is conceptual mind. This, through core thinking skills, starts answering or try to answer the questions. Okay, now conceptual mind sometimes, like for a child, it's not enough to answer all the questions. So it's always try to answer the questions, but it's not always there to give you the right answer. So we have to gain help from the outside. We have to gain help from our teachers. We have to get aid from the books, from the published literature, etc. But this conceptual mind has, or the core thinking mind has the ability that it differentiates, it start differentiating between right and wrong knowledge. So it will never allow the wrong knowledge to pass through it if it is fully developed. If it is fully developed, it is properly developed, it will act as a filter between right and wrong. So it will filter out, or it will gain only the right information, and it will satisfy the inquiring mind. Okay, once all the questions or all the related knowledge has been updated for a certain specific memorized knowledge, then we can use our creative mind, which basically through critical thinking do some creations, do some innovations. It's not something, when we say creative, it doesn't mean something absolutely new. We can do a lot of new things which called innovations, and these are essential parts of engineering as well. Creation is something different, but innovation is a level which usually we have to achieve. So this is how our human mind works. But unfortunately, in our societies, we are just restricted to it. We are just restricted, or most of the people are restricted to the knowledge mind, just the memorization, and that's it. The other three parts are mostly idle and they're not working. Okay, I'm not saying all of us, but at least high percentage, this is the problem. So that's why actually the importance of this lecture is there. Okay, so now I think we have gained enough knowledge about or conception about these three or four terminologies, and we can start looking at what benefits we get out of it. Like, for example, is it like a theory only, or really we get some benefits out of it? So how does intelligence or wisdom show up in our lives on individual basis, generally in our society, and specifically in our engineering businesses? Okay, so to start with, first of all, you see, the most important thing is that this wisdom creates two essential traits in us. Two essential traits in us. So these two essential traits are also not visible, but the results are always visible. So that's what I will try to prove, that if these two traits are available in a human being or in a society, then the result will be this. Otherwise, we will not get those results. So what are these two essential traits? These two essential traits are, first of all, differentiating between right and wrong, true or false, or sense and nonsense. That is a very important trait that is developed if the wisdom is fully developed. Wisdom mind or creative mind or conceptual mind is fully developed. We will have a skill of differentiating between right and wrong, true or false, sense or no sense, all these kind of terminologies. And this sense is known as sense of truth. So we'll develop a sense of truth. The other one is we have to arrange, once we know all the rights or all the senses, these are all correct things, we have to arrange these things in order of importance. And this we call it sense of proportionality or sense of proportioning and or sense of justice as well. So basically we are developing two senses. We can see the sense of truth and sense of justice. If you can imagine with me that if whenever we imagine like a justice in our courts, a justice sitting in our court, we always expect that there will be truth and there will be justice. So, and we always associate those justice with wisdom. Okay, so it's by default you can understand that if the wisdom is there, definitely truth and justice will prevail. But this has a different aspect in every task. Like in our engineering, it has different meanings, but in our general society, it has different meanings. And whenever there is like some investigation, it has different meanings. So, but generally speaking, these two terminologies will be there. So these two terminologies, let's look at these two terminology. How does it work? Okay, so this will be like more visible now. First of all, let's look, what is the source of knowledge for us? Source of knowledge for us. This is, we have institutes which from where we learn, schools, colleges, universities. We have society, which basically provides us different kind of knowledges. We have peers, our colleagues, print media, electronic media, social media, etc. So we have multiple sources of knowledge available over there. But now this is very important, that hard fact is that not everything we hear and read is right. Okay, this is our misconception of most of the people. If we hear from some specific person, if we hear from some specific media, I mean, that's right. So here we are misled. We should have ability to differentiate between right and wrong. So this will be the first sign of wisdom over there. Okay, so this how does it happen? We are bombarded with knowledge which has a mix of right and wrongs. Okay, here when I'm saying wrong, actually sometimes people get a little bit upset that I'm expressing something absolutely everyone knows absolute wrongs. But here wrong does not include only the absolute wrong, it is also relative wrong. I will explain it in a while that what does it mean by relative wrong. Okay, so absolute wrong, okay, sometimes easy to differentiate, but relative wrong, it's very difficult. It's a pitfall, it's a trap, and people usually get trapped into it. How this is I'm going to explain in a while. Okay, now this is basically we have a mix of rights and wrongs. Okay, and if we don't use our wisdom here to differentiate between right and wrong over here, our brain will be just like a computer screen. This is over here. On this computer screen, you can place, like for example, some information over here and some information over here, which is absolute contradiction with each other. But since computer does not have any wisdom, so it cannot drop differentiate between sense and nonsense, or it cannot drop wrong from the right. Okay, so when you click this one, it will start displaying that one. When you click this one, it will start a contradictory thing over there. So computer cannot come to know. So you can imagine, as I mentioned before, or you can recall that sketch, that if we just stick to our memorization center, we'll talk contradictory things at different times. We'll have a contradictory information in us. At one time, we'll be talking about one concept, another time, we'll be talking about another concept. So because we do not allow our wisdom part of the brain to differentiate between these two contradictory information and drop one of them. So it will be like that one. So, but we don't have to be like this. And if we have, like, for example, wisdom, and we have this sense of truth, we'll drop out all our wrongs. But as I mentioned before, that these wrongs may not be the absolute wrongs. There could be relative wrongs. This can be easily explained through this very common example. I think almost all of us must have gone through this example. This was an experiment that was performed on 6-7 persons who had never seen an elephant in their lives. So they were blindfolded, and the elephant was placed in front of them. So each one of them caught part of the elephant, and they explained the elephant based on their relative wrong information. Okay, some of them who got hold of the body of the elephant, they said it's like wall. Who got hold of its trunk, they said it's a snake. And the tail, it's a rope. And then who held the leg of the elephant, they said it's like a tree. So you see, all of them are they are right in their framework, but they are wrong when we say on three-dimensional basis. So absolutely wrong. They're relative wrong, but in overall sense, it's absolute wrong. So this is very important. Sometimes, due to our partial understanding of the things, partial comprehension of the things, which is very common in our society, we think that we are right. We are much more confident. We are much more confident of our knowledge. We say, no, this is absolutely right. We are absolutely right. Because you are holding the trunk of the elephant, and you feel it's like snake. If someone tells you, no, elephant is not like this, since you are not getting the full comprehension of the elephant, you are wrong over there. But you feel that you are not wrong. So that's why the next very important lesson is that comprehension should be complete, not even 1% lesser. Even if you have 99% perception about something, you create perception or comprehension about something, then you may be misled at many places because of your partial knowledge. Okay, after doing this one, then I'll move back to the other sense once we have, like, for example, how we do it, how to do it. I have shown in the previous slide that all W's have disappeared, but how these W's could be disappeared. This we can understand from this pyramid, which is, we call it wisdom pyramid. Usually what happens at the base of the pyramid, we have this mix of true and false information. We are reading books, we are getting information, and that is a mix. So we have one truth and we have several false. And this is usually from discrete, which is called knowledge, just knowledge. And this knowledge exists like this one if we don't do any analysis. Okay, if we do partial analysis, some analysis or little analysis, we can remove some falsehood, but still falsehood prevails. Okay, we do more analysis, which we are calling it partial analysis. Now we can still drop more falsehood over there or the wrong information over there. Once we do the complete analysis, then we will be left with the truth. So this, how we do it within our brain, this is the level of the core or critical thinking. Okay, so the more developed our core thinking skills and critical thinking skills, will be able to drop wrongs from the rights. Okay, so how this happens now. Next is this: if we are, like, for example, left with all the rights, the next very important trait or the requirement is to arrange it into an order. We called it highest priority level to lowest priority level. This is very important also. And we do using our sense of justice, which is the second trait of the wisdom. This is a very important property. This is a very important property when we are acting as engineers. While we are as designers or we are contractors, we are doing construction. These are very, very important. In our general society, in our general lives, this is also very important. Like, for example, we have to differentiate between what is the most important thing, okay, and what is the least important thing. Okay, then we have to arrange everything like this. Only then we'll be doing the justice to the things. We will devote more time to this one and we will devote lesser time to this one. Okay, so time is one thing, effort is another thing, attention is another thing. So all these precious, we can say, things we have to spend on these. So if we arrange these in wrong order, like, for example, we keep like this one, we'll definitely end up in wastage of our energies, and we will be not focused on the most important thing, and we'll be focused on something lesser important. We'll spend more time in it, give more attention to it, and we think that is more important, but that's not true actually. So similarly, if we do something like this, this is even worse. We have brought the least important thing in the second rank. Okay, so this we are not doing justice. So whether we are having in our general lives, we are behaving in our general lives, or we are doing some engineering projects. Okay, so that's very important that we should have that one. What's the result of this one? Once we do this thing, the result will be, like, for example, we'll have an ordered procedure, we will have ordered steps, we have correct sequence, we have right priority, and we have right importance, and we will have due weightage. Okay, so all these terminologies I have just listed down over here because, as I mentioned to you, that wisdom and intelligence, they have little bit different terminologies or actions when we are talking about our engineering business, and whenever we are talking about, like, for our general lives, general behavior, human interaction, etc. But we are so that's why I'm just expressing in a general terms, and then we'll be keep on moving towards our specific task. Now, what will happen? What will happen if we do something like this? For every task, we can define these lines, different colored lines. We'll have red lines, we'll have yellow lines, and we have green lines. And as engineers, we should be well aware of these lines. Like, for example, whenever we design a project, we should have certain red lines. Those are, like, for example, the most important part of the design. Okay. Then we can have, like, for example, green lines, and we can say these are least important. Okay, important, but we can have flexibility in it. We can have different options for green lines, but red lines, no. Similarly, for the construction projects, or during the construction projects, red lines must be defined properly. Usually we do define, but if we define wrong red lines, like, for example, the most important part of the project, the critical part of the project, we always get flexibility in that one. We think we can have this one in lieu of that one, or that one in lieu of this one. Then it means that we are jeopardizing the project. We are spoiling the project. But green lines, we should be flexible. But what we have observed, like my experience, my personal experience, that usually, since we do not define these, or we define in a wrong manner, there are always conflict on the projects, because either we are hardliner and everything is red line for us. No one can cross those red lines. We don't allow any flexibility in the design or the construction process. On the other hand, people are so flexible that they're allowing everything. They're saying, oh, we should be flexible. We should allow this variation. We should allow that variation. But both of these are extremes and wrong. Okay, we always in our lives, always in our projects, we should have, or it by default it has red lines, yellow lines, or green lines, or even more colored lines. I have just written 3 colors over here. We can have 7 color lines. So each color line must have certain limitations. Red lines, no compromise. No compromise. Green lines, yes, there is a lot of flexibility, a big spectrum. This aggregate gradation, this concrete strength, okay, we can allow within this spectrum, there is no problem. Red line, okay, this is very important, and we cannot have even 1% lesser than that. So this is how wisdom, knowledge or wisdom basically plays its role. Okay, so if we have well-developed knowledge and wisdom, and the people are there to exercise it, we'll be able to define in a right manner these lines, and then the result will be like we'll have we'll produce highly successful team members, leaders, or managers. Okay, then they will know each and everything, because they will be using the knowledge and wisdom to accomplish this thing, and will have most efficient utilization of energies, time, and efforts, because we'll defining the most important things and the least important things. So we'll be diverting our energies accordingly. We'll be distributing our energies and times and efforts accordingly. And the result will be that both schedules and quality will be met. So this is the most important thing. And this is how you can understand that if we go just in a random manner, we move in a random manner, we'll be losing the schedule, not aware of what are the red lines. We are blindfolded like those 6 persons, and the elephant is in front of us. So we are very sure that we are doing the right thing. We have caught the tail of the elephant, and it's like a rope. So we are beating about the bush, and we are losing everything. The projects are being lost, and the projects are in problem, and schedules are not being met. All this happens if knowledge and wisdom is lacking. As I mentioned earlier, because these 2 traits are not visible, no one can judge, or there is no meter that you can put on the head of a person, and you can say that this person has this much knowledge or intelligence or wisdom. Those will show up when he will be put to test on these things. Okay, so now once we have defined how does wisdom helps us generally, and to some extent specifically, we have to move now to how this wisdom helps us in engineering. So more specifically in engineering practice. Okay, so most of this discussion I will do through examples, and I'll do some deep analysis of some of the examples and some general discussions. But before that, it's very important to recognize that as engineers, we are dealing with three entities. In fact, whenever I have asked people that how many entities you deal with, they just tell me two things. They say we are dealing with processes and we are dealing with materials. But they forget that we are dealing with humans also. We are dealing with persons. So if we don't know the science of the persons, if we don't make concepts for their persons, I mean, the most important part of the construction teams will be definitely losing. So if we just concentrate on the science of the processes or understanding of the processes and material, will be lost. So we have to consider all these three entities while we are discussing knowledge and wisdom. So behavior of each of these entities actually has a science behind it. Now, it's very important for me to clarify, because whenever I have delivered such kind of lectures or I have done similar discussions, engineers, they become very sensitive when we say science, when you use word science, because they say, no, we are engineers, we are not scientists. Actually, this is their fallacy. This is a fallacy. How come this is a fallacy? Because they cannot understand. They don't have a concept of the word science. They don't have the intelligence of the word science. Actually, the scientist is a person who creates new science. Okay, but the engineers are the persons who use this science, use the already existing science for engineering purpose. So if they don't understand the science behind the concepts behind these processes, materials, or persons, definitely they will be lost. Okay, so if they are allergic to word science, there will be a problem. So we have to understand that we are not scientists. We have to understand and apply science. Understand means intelligence, and application is the wisdom. So we just call it science, not as a scientist. Okay, so it was important. Otherwise, some people stop listening once I start using word science. So understanding of the science, it's just like conceptual comprehension. That's what I expressed earlier. Now, processes and materials, either natural or man-made, are controlled by physical laws. So we have to understand the science of these physical laws. And then humans actually are controlled both by physical and psychological laws. So there is a psychology, and that one over there. So this one, I will start explaining through examples, as I mentioned earlier. After this base introduction, it was an experiment that was performed on the engineers who were involved in designing infrastructure, designing facilities and infrastructure in areas where temperature falls to zero or below zero. Okay, so just to check their intelligence and wisdom for this subject, they were put up with two set of questions. This is one of them, and you can see here, this is basically an intelligence or core thinking based question. And this is related to anomalous expansion of water. I think as engineers, we all know that water has some abnormal behavior, anomalous behavior, when it goes to the freezing point, when its volume behaves not in a normal way, or it's in contradiction to what usually we have the concept. So basically, this concept is the key for the analysis and design of infrastructure and facilities when we are talking about areas where the temperature falls to zero or below 0 degrees centigrade. Now, this I will show over here. Now, this is basically a plot between volume and temperature for water. So we can see here that the normal behavior continues, like water keep on shrinking up to 4 degrees centigrade. But here you can see from zero, there is a different behavior. So there is the missing behavior or basically the hidden behavior for this one is between 4 and 0 degrees centigrade. The question was that what is the volume at 2 degree centigrade? So five options or choices were given, which are shown over here. Different engineers or different group of engineers answered differently. Some of them answered like this one. Okay. And they said that it is 10, which is false. Some of them made the model like this one, which is also false. And some of them, or most of them, actually answered like this, and they said that the behavior should be like this. But this was also false, or explained the behavior like this one. And this was giving a number of 34, which was also false. The right answer was like this. So the model was not like, for example, not going like this to 0 degree centigrade. Rather, it goes to 0 degree centigrade. Then at constant temperature, there is an increase of volume of the water to this number, and then it comes down. So the true answer was this one. Now, unfortunately, 70% of the persons gave this wrong answer, this one. Okay. And 5% each approximately gave these other three wrong answers. Okay. And 15% gave the right answer. So once they were given this one, the second set of question which was posed to them was to use this application. So wisdom or critical thinking based question, that they have to use this for different designs, like, for example, design of fish ponds in freezing zones, like, for example, how plant growth or uptake is important during freezing seasons, weathering of rocks or geological models, how it's applied, designing of cold storages, designing of water bodies and reservoirs where there is an increase of volume during this behavior, and then design against infrastructure damage like roads and pipes and other things like tanks, etc., or water storage bodies. So now if we look at this one, the persons who opted this answer, which was in fact a wrong answer, they basically designed all these or over-designed these things. When they were given a specific example, I'm not showing that specific example, but when they were given this specific example, they basically over-designed it. The persons who opted this question, in fact, this answer, in fact, they designed in a right manner, in fact. Now, what is the difference between these two? What is the difference between, or what is the implication if we say like the behavior is this much, or the behavior is like that? In fact, what happens that if we go for this one, then what we do, that if we are given an area where the temperature drops to 0 degree centigrade for some limited period only, for limited period, say a day or so or few hours, and then it rises and then it comes back again for few hours only, then there is no need to design against this phenomenon. Okay. But they designed it because they were given, like, for example, that data, and they designed it against that one. So it was an over design. What happens actually, that for that smaller period of time, the rise of volume or increase in volume is very small as compared to the rest of the volume that will be gained when the persistent 0 degree centigrade is there, like for several days, temperature below 0 degree centigrade prevails. So that's a very important example, which shows that how only a small part of the concept was missing, and the people were, or the engineers were, over designing that thing. Okay. So we have to be careful. We have to be careful for our 90% concepts or 80% concepts or 99% concepts even. This is always very dangerous. It's a partial knowledge is very dangerous. Okay, this shows that one. So I will show now even more examples right now. on different aspects. Now, as I mentioned before, that we are dealing with three things. We are dealing with processes, we are dealing with materials, and we are dealing with humans. Okay. Under processes, we have design processes, we have construction processes. Under materials, we have concrete, soil, asphalt, steel, and we have mixed designs. Okay, mix of these things. And when we are dealing with humans, we have humans of different trades, we have skill types, skill levels, etc. So we have there is some mic should be muted.
I'm trying to figure out who is.
Mr. Shazib,
Shazib, please mute your microphone. Please, I will request all the participants to keep their microphone in mute position. This disrupts the flow of the speaker. So kindly let's have a continuity in the lecture. Dr. Saab, please start your lecture again. I'm sorry
Okay.
for this interruption.
Okay, so that's okay. So as regards humans, we are dealing with humans of different trades, different skill types, different skill levels, and definitely a big spectrum of variation when we are dealing with humans. So let's look some of the examples. But before that, we have to understand that we have to see that whether we have got an essence of each process, whether we have got the basics of each design step, or we have, like, for example, when we are dealing with human, we must understand their psychology. Generally we classify under industrial psychology. We say industrial psychology. So that's very important. So let me discuss examples for each of these. Design and construction processes. I'll start with a very basic example and try to explain that how we can judge whether the wisdom is there or not. Like, for example, bearing capacity against shear failure. Now, all of us as civil engineers or as geotechnical engineers, even as civil engineers, we know that there is a factor of safety against shear failure of 3. But we are using it blindly. Have we ever thought, or let me put up in these words, that if a person knows that what is the basis of this number 3 and why this number 3 is there, and under what conditions I can change this number to 3.5, 4, 2, 2.5. So what's the relationship of this number with my shear failure? Then it means that he has got the intelligence and wisdom of this factor of safety or the shear failure. But if we are blindly following this 3 and we don't know why it is not 3.5, why not it is 2.5 or 2 or 1.5, under what conditions we can play with it, we can have, like, for example, a variation in that, it means the intelligence and wisdom of bearing capacity is missing. Okay. Next example again is related with bearing capacity, like serviceability limits. Usually we go blindly with 25 and 50 mm settlement criteria for isolated footings and raft foundations respectively. But sir, can you mute your mindset?
I'm sorry, it was my mistake. It was unmuted. Please go ahead.
Okay, these serviceability limits. So do we know that what is the philosophy behind this 25 and 50? If we know the philosophy, we can change it. We can go from 25 to 35, or we can reduce it to 15. Under what circumstances we can increase 50 to 100 even. So if we know the basics or the science behind these serviceability limits, why these were created, how these were created, what's the relation of these numbers to the structure sensitivity, to the foundation sensitivity, then we can do innovations, we can do changes, we can have an economical design. We can have, like, for example, we can produce quality in our design. So this is very important. So if these concepts are there, I'm not saying that these concepts are not there. If a person has these concepts, definitely he has gained intelligence and wisdom. But if not, I mean, it's a vice versa. Like for retaining wall design in our societies, what I have noticed that we usually go with strength-based designs. We don't have in comprehension that what is the role of stiffness of the retaining walls in the design. So if we have to do design, retaining wall design using the stiffness criterion, then how we'll have to do it? What's the criteria? Do we have to allow, like, for example, 5 mm for a retaining wall? Under what circumstances is it 5 mm? Under what circumstances it is 25 or 50 and so on? So all that understanding, if it is there, then definitely wisdom has been gained. Otherwise, it's absent. Like for ACI code, like we do have also, similar to the bearing capacity, we have factor of safety. But do we know why there is a factor of safety of 1.4 and 1.7? Can we reduce it to 1.3 or 1.6? Can we increase it to 1.8 or 2? Under what circumstances we have to play with it? If we know the science behind it, again, the concepts behind it, we can do it. And this is how we can have like the most economical designs. And it also, does it affect the life of a structure? Do we know that if we're designing for a 75 years old structure, like the life of a structure as 75 years, or if we have to increase the life of a structure to 100 years, what changes in the design we have to do? If we know this theory, if we know this science, definitely corresponding intelligence and wisdom has been gained, or vice versa again. So now, as regarding compaction, which we perform during any construction process or even design processes, do we know what is the effect of overcompaction? Fine. What's the effect of overcompaction? If overcompaction has occurred, can we redo it? Usually I've seen engineers confused in the field that if there is an overcompaction, if there is what we have to do? Can we redo it? Can we rectify it? If there is undercompaction, what to do? Okay, what is the effect on specific types of soils and aggregates? Like what happens to the sands if we undercompact it or we overcompact it? Similarly for the clays. And what happens if we compact on the same dry density, which is a very common criterion in our engineering business or engineering specifications. But if we compact it on the wet side of the Proctor curve or the dry side of the Proctor curve, what will be the effect on the engineering properties? So if we have gained all these understandings regarding compaction, then definitely intelligence of the compaction is there. Okay, let's have more look at the more examples regarding materials. Now, usually in engineering practice, we see gradation concept. Like, for example, structural fill or base course, we have a gradation concept. That if the gradation of that material matches with it, then fine, it's acceptable. If it does not match, then it's not acceptable. What's the relationship of gradation with real behavior? If we know the concept of or the relationship of gradation with the real behavior, engineering behavior, whether it is a stiffness behavior or a strength behavior, then definitely we can play with the gradations, or we can innovate with the gradation in more real terms. We can do some innovations. We can say, okay, if we have to achieve these properties, okay, even this gradation, which does not fulfill our specification, is acceptable. So concept is very, very important for everything. Proctor compaction test. Now, two different type of Proctor compaction tests exist in the market. Like one is standard and what is modified. But whenever we ask engineers, okay, do you know what's the difference? They always tell us like the procedural difference, which is knowledge-based difference between these two tests. That how a modified is different from number of blows, number of layers, etc. But what is the concept behind why a modified test is there and why standard is still there? And under what circumstances standard test will become our specifications? And what other circumstances modified will become our specifications. Modified will control our specification. Modified will control our construction process. So all these concepts are very important, and intelligence and wisdom is required to understand this one, understand and apply. Okay, for asphalt concrete, again, the same, similar to soils, it's a very like common to see, like we overcompact in most of the circumstances, but we don't without understanding the role of air voids in the life of the asphalt concrete. Okay, if we understand that what is the role of air voids, because we are creating air voids, not the density. Okay, but what we achieve in the field is the density. Okay, but behind this density, the concept is the role of the air voids. So if we overcompact, we are happy that we have more than what our target, we have achieved more than our target. But basically, we have deteriorated the pavement. We have cut down its life by several years sometimes. So this is how I'm just trying to give examples in a random manner. Like for concrete mixed design, now concrete mixed design is usually based on strength parameters. What's durability of that concrete? Although it's hidden over there, but does workability affect strength or durability? Sometimes workability reduces the strength but increases the durability. So we have to see what is our target. Is strength of concrete our target, or durability is our target? It should be durability, but in most cases, when we have interviewed young engineers or even experienced engineers, they say strength is our criteria. They don't understand how to express durability, how to bring durability in the specifications. But durability is our requirement. Sometimes we achieve lesser strength, but if it is durable for 100 years or 200 years, it will definitely fulfill our requirements much more than just based on the strength criteria. Okay, as regards rocks, also there is a great misconception going on among the communities. Like for example, when we say shale, it means shale for us, but shale has 7 different varieties. Limestone has 4 or 5 different varieties from engineering point of view. Sandstone has similar couple of varieties against there, and they have a very low strength sandstones and very high strength sandstones, and vice versa for the limestone also, for shale also. Some shales are as hard as very hard rocks, and some shales are vulnerable or very weak like soils. Similarly, we have conglomerates which you can break with our hand, and there are conglomerates we cannot drill through. So that's why a concept about the rocks is also very important. We have to understand the complete spectrum of these rocks and how this complete spectrum is related with the engineering requirements, our engineering requirements. What type of sandstone is suitable for us, whether it's for road building or for foundations, for any other infrastructure, etc. So that's also a wide spectrum of knowledge is required, or comprehension is required over there. Now, rest is regarding humans. Actually, humans, basically, they are controlled, as I said, that through psychology. There is a complete subject on it to understand human psychology who are at work. That comes under industrial psychology. Understanding of the industrial psychology, or the concepts gained through industrial psychology, must be applied. Otherwise, we'll be keep on hearing, or we'll be keep on experiencing something like that all humans are like machines. Okay, so they have to produce. They have to produce, and they have to produce similar like machines. But even machines need maintenance, rest, etc. So for humans, sometimes we do not consider these at all. All engineers can do all the tasks. This is a fallacy. So this does not come under concepts. All engineers have the same kind and type of ability. We can make every engineer do the same kind of type of job. This is again a fallacy. Every person should perform to the maximum every time. I mean, we have a person working with us or under us, and we think that he has performed excellent yesterday, and today he should be doing the same thing. but he is being controlled by psychological traits. So he may not be producing to that much efficiency today. You have to control it. You have to see the science behind science to control the humans. Okay, so that's very important. Every person has the same level of training requirements. This is also fallacy. Some people require more training, and some people have lesser training requirements. So these are some of the questions I have put forth to define that every human being is unique. No human being is useless. In fact, is a unique. So our job is to find out the right person for the right job, to place the right person at the right job. You remember, this is one of the trait of wisdom, the sense of proportioning, sense of justice. So if we put a person which is good at, for example, long jumps, to do the high jump, definitely he will fail, and vice versa as well. So that's very important. And this can be learned from the human behavior normal distribution curve. Okay, all human beings, or most of the human beings, they are an average behavior, and there are exceptional behaviors. So even average behavior, humans are not useless. They are very useful. I'm repeating this thing. No human being is useless, but they are unique. We have to understand the capabilities, the specific capabilities they own, and then we have to use them accordingly. So we have to understand 85th percentile concept regarding humans. So there are 15% humans who are exceptional in behavior. Others are different in behavior, not even average in behavior. So this is just to express that that we have to learn the science behind the human behavior also. Whenever we are, so the importance of science behind the human behavior, so that we can have intelligence about the humans, and then we have to use this our wisdom to use them accordingly. Now, as I mentioned, that we have learned that the importance of wisdom, the understanding of wisdom, the importance of wisdom, and then specific importance of wisdom in our engineering practice. I have tried to cover some examples, definitely not the complete spectrum. Now, the very big time question always arises: how to develop wisdom, how to develop intelligence and wisdom, in fact. So how can we can make changes in our learning attitude, or our institutes, etc. So as I mentioned before, that our knowledge has different sources. Okay, so why this question arises, that how to inculcate wisdom in our society, is that unfortunately a high percentage of these sources provide memorization based learning. There is a very quick dissemination of knowledge, and there is a bombardment of knowledge. So every person is just memorizing those things without understanding them. So they have, like, for example, do not furnish intelligence or wisdom based learning, or the learning based on the understanding of these things. So we just memorize, we have a lot of knowledge available. So we just grasp that knowledge, and just we keep that knowledge without understanding these things. So that's why this question arises. So that how to develop wisdom. Now, the question is, this question is similar to, as I mentioned, that all human beings are highly useful. No one is useless. That's it. So the next question is, does everyone have a trait of wisdom? So the question is big yes. Every human being has the same form of wisdom in it, without any atom difference. Okay, the only difference is that the development, because it is analogous to our body muscles. Okay, I'm just trying to explain it with respect to our body muscles. Now, all of us have muscles, but do all of us develop all our muscles? Okay, and to what extent? So every one of us develop our body muscles. First of all, there are many muscles which basically we do not develop at all. Specifically, let me say, only the bodybuilders, the persons who do some gym trainings, they are able to develop many muscles which we never do ourselves, or we cannot do ourselves. Okay, then do all of us develop muscles to the same level? So we have been given muscles by nature. Okay, all of us have been given muscles by nature. So, but the problem is this, that either we do not develop or we develop it to lesser degrees. Okay, we don't develop to high intensities. Okay, so more we develop our muscles, the more powerful and energetic they become. So this is synonymous to or analogous to wisdom now. That all of us have wisdom, but sometimes we do not develop it at all. Okay, and what happens then? It's same thing. Like for example, if we do not use some of our muscles at all for a longer period of time, they become useless. We call it muscle dystrophy. We call muscle dystrophy. This happens with age also. The more lethargic we becomes, lazy we become, we do not do exercises, we do not do walks, we do not move our muscles, they become useless, and there is called dystrophy. So it's a non-return type of a situation. So same thing happens with the wisdom. So if we do not use our muscles, so muscles dystrophy occurs. If we do not develop our wisdom or use our wisdom for a long period of time since childhood and then during 20s and 30s, there is high likely chances that our wisdom center in our in human brain or human mind will become redundant. Okay, so it's very important that we have to develop it, we have to keep on developing it, and we have to keep it to toned like we do with our muscles. Okay, so wisdom is there, but it depends on the person that how he wants to use it. Okay, so same fact applies to wisdom. So this is a fact. We have to keep this fact in our mind. So it does not mean it's something inherited in a person and he says that it is there, I'm not using it and it will survive. No, a day will come that it will be no more there. It happens to the generations also. So it's very important that we keep our core thinking centers and critical thinking centers alive. Okay, so this is the message basically. Okay, now what happens actually, before I go to that one, that wisdom is developed through imagination. We have knowledge and then we develop imagination for the processes, for the materials, and for the humans. Okay, we have knowledge and then we have complete behavior models. Now as engineers, we can well understand this model, behavior model. So each process, material and human in our mind will have a similar sort of highly complex behavior model in our mind. If we have developed our intelligence and wisdom centers very nicely, then we will have a very nice and highly predictable type of behavior model in our mind. We put input 1, input 2, and it will give you the right output. Okay, but if we have the wrong model, we always try. All human beings try to have behavior models, but if these are not based on a real good understanding and then application, these will be wrong models. So always it will give you wrong results. Now this model seems to be complex, but it's based on only on 2 inputs. But when we are dealing with humans, we are dealing with materials and other processes. We'll have multiple input behavior models. We will have multiple input behavior models. Those will become more and more complex. But those become very easy because human brain is capable to handle these behavior models. So that's why the statement which I showed you on the last slide, that imagination is more important than knowledge. Usually this statement is attributed to Albert Einstein, but some people say that it is not. But this statement is quite imaginable, that just having knowledge and then we are converting this knowledge into concepts. These concepts become a behavior model, and then we can start using this model using our wisdom. Okay, so this is regarding so what we have to do, because question is that how we have to develop wisdom. Now I think it's very clear that we have to lit up 3 different centers in our brain. We have to lit up inquiring mind, we have to lit up core thinking mind, and we have to do our creative mind, okay, which is basically the critical thinking. So if you look at the terminologies, I think it becomes very easy that we have to lit up our inquiring spirit, our inquiring ability, ask questions, asking ability, and our thinking abilities. Okay, so we have to, how we can do it? How can we do it? Okay, first of all, we have to invoke inquiring or inquisitive minds. We have to develop this thing, and then we have to learn phenomena rather than the process, which is insight through core thinking. And then we have to use these insight not through data and examples, but in the real input, in the real form. Like, for example, the real projects. We have to use it, not through data and examples. This is very common in our society. So we have to inquire in. Let's look at these one by one. First of all, how we have to create invoking or inquiring minds. I think this is very, very easy. We should get our people accustomed to ask all type of questions about everything. Okay, especially at the grassroots levels. Okay, at the childhood level. Okay, for the early age children. They should get accustomed to ask every question about everything. Why, how, what, how, why, where. And we have to satisfy them. The most important thing is that we have to satisfy. They have to develop habit of contemplation or to reflect. Okay, contemplation and reflection. These are two very important traits, and these start with asking questions. Okay, so this is very important. But the most important thing that we have to get answers for them, or they have to get answers for themselves from authentic sources only. This is very important to differentiate between an authentic source and unauthentic source. And this is what society needs to learn also. Every source I mentioned to you, every person which we see, everything we hear is not right. So we have to learn how to differentiate between authentic answer and unauthentic answer, or a wrong answer or a right answer. Okay, this is actually again science. Okay, we do have that judgment. We do have to develop that judgment.
Dr. Habib, I have to make one announcement. Sorry for the interruption.
Yes,
Gentlemen, the question answer session, as I have informed you earlier at the start of the lecture, that there will be a 20 minutes question answer session at the end of the lecture. But I cannot allow anyone to ask questions through the microphone. So if you have questions, please start writing in the chat box. I will read those questions and Dr. Saab will answer them. Thank you.
Okay, sir, thank you. Next is that we have to learn phenomena rather than the process only. I think we have enough discussed on it, that we have to learn the science behind every process. Okay, and this we can just to give you two small examples on this one, and one is related to Newton's third law of motion. I think all of us are very well aware, like action and reaction are equal but opposite in direction. But you know that this is not always true. We think that this is like a universal truth. Okay, it depends upon the energy of the system. It depends on the energy dissipation capacity of the system on which you are applying an action. It depends on the momentum of the object, which is basically hitting that object. Like, for example, if we throw a ball on a wall which is flexible in nature, on an object which is flexible in nature, the reaction will never be equal to the action, because some of the energy will be absorbed by that system. So if we do not understand these, I'm just giving you one glimpse of that one, okay? Stiffness of the system providing reaction is very important to understand this law. Okay, otherwise we'll be goofed and we'll be just blindly following this statement, and we'll say, no, this is hard and fast rule invented by Newton, and no one should speak against it. Okay, but see, in many circumstances, this law does not hold. So again, if we understand the science behind the whole system of action and reaction, we can understand this thing. The other thing, which other example pertains to the anomalous expansion of water, as I said that I have explained earlier. So it is expansion. We have to understand not process, but the phenomena. What is the phenomena? How the water molecule structure plays its role. If we understand that one, I think it will be very easy for us to design appropriately. If we do not understand, then we'll have some like memorization of the concepts, even some memorization of the concept. This is a very strange terminology, memorization of the concepts, and this is also common in our society. Sometimes we have memorization only, and other is memorization of the concepts. But it's an understanding of the concepts is important. Okay, so that requires an insight into it. So everything requires an insight development. So that is through learning phenomena. Okay, so third one is learning uses rather than data or examples. What happens actually that it's very common in our institutes that we put our students to hundreds of examples and problems and think that they have learned everything. Okay, but this is a useless exercise in my viewpoint. If concepts and basics of a subject are not clear, the 100 first example will deceive you, because you have learned 100 examples. You have kept in these in your mind, and if you get similar sort of problems, you can handle. You may be able to handle, but little bit variation out of it will deceive you, and you will not be able to design. But if concepts and basics of the subjects are clear, even thousands of new problems can be solved. So this is the beauty of learning three things through uses, through direct uses, rather than through solved data and examples only. This gives students and teachers a very good feeling in our society. I'm not saying even again that it's applicable to 100% of the cases, but at least 70-80% it's true. Okay, rest 20-30%. Okay, people are trying to have a different learning habit. So there are three things over there, and I will sum up now. Everything that we have three basically targets required to develop wisdom. Just to sum up the last three slides, one is to understand, to ask question, to lit up the inquiring mind, to lit up the core thinking skills, and lit up the critical thinking skills. So these three I have explained through some of the examples. So as regard conclusions, I think I'll sum up, but I will explain some new things over here also. Like wisdom is basically what it is: imagining or creating behavior models in our mind. So removing wrong from right and ordering truth in a sequence. Okay. So wisdom is achievable by any one of us. This is a fact. Okay. By three steps. Okay. Invoking inquiring minds. And this is more appropriate at the grassroots levels. Learning basic phenomenon rather through core thinking skills, and learning application of the concepts through critical thinking skills. Okay, this is how we can develop that one. And when we use these models, we produce most efficient utilization of energies, times, and efforts within our engineering projects and generally in society. And we produce highly successful team members, leaders, or managers. And in this way, both schedules and quality are met in our projects. And the next is little bit like, for example, I want to stress that not everything known to us or taught to us through institute is right. And this is basically George Santayana, who is one of the psychologists. He expressed that a child educated only at school is an uneducated child, just disseminating knowledge rather than the knowledge and wisdom. So that's important, is that we have to gain a comprehensive understanding of the things, and not at all a partial understanding. Partial understanding will definitely have problems. Like this example I have given you earlier, it will create traps in your life. Okay, life has traps for the partially knowledgeable people. They are always highly confident, very prevalent over there, and they are very high confident and they have a very high sense of conviction that they are right, but they are wrong. So you can always keep this example in mind whenever you feel that you have not full comprehension and you are stressing on something that this is right, or you are fighting for it. So always get full comprehension before revealing. Problem is this, that why we understanding sometimes, definitely everyone asks questions at the intelligence stage, or when a child grows or human child grows up. But the problem is this, that why we cannot get full understanding is due to our laziness. Because 90% understanding, this is a rough estimate, but this is established fact. The 90% understanding of anything requires 1 hour. The remaining 10% understanding requires about 4 hours. So it means 4 times 10, last 10% requires 4 times more than. So we have time, we're lazy, we don't want to engage our brain for longer period of times. So we can go up to 90% understanding and we'll leave the 10% understanding, and that will not make us professionals. That will not make us professional. So we'll keep our normal thinking alive, but keep our core or critical thinking dead over there, or we close our core or critical thinking. So it's again analogous to the laziness, physical laziness of human beings. So if our muscle dystrophy or muscle disuse occurs when a person is physically lazy. So if someone is mentally lazy, definitely he will revert to normal thinking. He will not stress his brain for core or critical thinking. So here there will be a pitfall. There will be lack of full understanding, and there will be no professionalism over there. Okay, so to sum up the wisdom things only, that we have to invoke inquiring and thinking. Okay, I mentioned that laziness prevents us. Okay, inquiring is there, but thinking ability sometimes basically requires more stress on our brain. So if I'm mentally lazy, we don't stress our mind, or we don't want to stress our mind, or we do have a culture of not stressing our minds. Okay, that's what stated by George Bernard Shaw a long time before. He said that only 2% people are real thinkers. They use their brain to the fullest, and 3% of the people think that they think. Okay, they think that they are thinkers, but they are not using it appropriately even. And 95% people would rather die than think. So this was his statement. You can have your own judgment regarding that one. Okay, another statement by Richard Feynman is he's a physicist, actually, American physicist, and he basically expressed his concern regarding the education. Like, he can say that you cannot get educated by this self-propagating system in which people study to pass exams and teach others to pass exams. So if this philosophy is there in our society, nobody knows anything. This is what he said. And he said that you can learn something by doing it yourself, by asking questions, by thinking, and by experimenting. Or this is the message, I think, was throughout my lecture, that we have to change our learning habits in this manner. Okay, but the last important thing is that even if we do, say, for example, develop inquiring minds, if we do develop thinking minds, we have to remove bias, because this is the biggest hindrance in developing our intelligence and wisdom. We always bias towards something. Even if we see the truth, we say no. Our bosses have done like this one. Our parents have done like this one. Our society has always done like this one. This is a very big pitfall again. That is basically created by a biased mentality. So this is an anti-wisdom trait. So we have to remove, while in any education system, we develop inquiring minds and we develop thinking minds. We have to remove bias from it. That a person, if he sees truth, immediately accept it. If he sees something wrong, he should say it wrong. So this means there is no bias. Otherwise, there will be a bias. We are biased towards some persons. We say he is always right, and or my boss is always right, etc., which I have explained. So this is an anti-wisdom thing. The last thing, just a couple of slides, that's very important, and everyone should have this question in mind: where does artificial intelligence, a very commonly prevailing term these days in our lives, where does artificial intelligence resides with respect to our human knowledge, intelligence, and wisdom centers? In order to understand this one, we have to go back to the first industrial revolution in 1760, when mechanization came into picture. At that time, humans had 4 different faculties. One very important faculty was physical effort or physical input of humans, which we call manual labor. Okay, at that time it was very much pronounced, or before that it was very much pronounced. So with mechanization, a big time question arose. Said that mechanization is there, so machines will be replacing humans. But this was not true. There was a diminishing effect of manual labor. Manual labor still exists. There is a lot of contribution of manual labor over there. But mechanization actually removed part of the effort which humans were doing. And the nature wanted us to do something else over there. So nature had a plan that humans should do scientific revolution now. They should move away from the physical efforts. They should get de-engaged or disengaged from the physical efforts and use machines instead and do scientific revolution through knowledge and intelligence. And this is whoever individuals or nations, they understood this fact. They basically accepted this thing, and they replaced humans with machines, and they used their knowledge and intelligence more and more to do scientific revolution. Whoever did not follow that one and they stuck over there, basically machines surpassed or superseded that society of humans. And we can well understand what I mean. Okay, now same concept prevails over here. The artificial intelligence is there, and artificial intelligence, in my viewpoint, stands over here. It cannot supersede human intelligence. It is partially replacing human intelligence. Nature has given this to us to free our intelligence center partially, to free our minds partially, so that maybe the nature has planned for us to use our wisdom to the maximum. Now the time is coming where wisdoms will play more role than machines only. Okay, so whoever understands now this thing will definitely succeed, will be successful in the coming times. And whoever will not understand this thing, do not use wisdom, and we're stuck within artificial intelligence and human replacement concepts. This artificial technology will surpass or supersede us, and we'll be not good professionals. We'll be dependent on some other professionals to do our work. Okay, so this was my last message. Now, thank you very much. And if there are any questions or discussion, I'm ready to take up. Yes, Mr. Tyson.
Thank you very much, Dr. Saab, for your such an enlightening lecture, full of knowledge, and I would say a unique lecture. So let's go through the questions first. We have the first question from Khalid Bashir. It is a comment and a question. Very good presentation. Thanks to PSCE and Dr. Habib. This era is digital knowledge era. It is difficult to distinguish between right and wrong data and knowledge. How to arrive at right knowledge? You, Dr.
Saab. In fact, if we look at this slide, he's right that, and I express this very important point, that we have to get answers from authentic sources only. Okay. Now, from engineering point of view, let me explain from engineering point of view. I think that will be valid for other disciplines or other values also. Like for example, we have conference papers, we have journal papers which are peer reviewed, high level journal papers, books written by eminent people in their fields and peer reviewed by the other people. There are publishing societies basically which are very well known. So if we have to get truth or we have to get right answers, we have to choose well published or well established published journals, okay, or books. Okay, otherwise there are a lot of books available which authors we do not know at all, and their personal opinions, based on their personal opinions. We have to avoid personal opinions of people. We have to see if he is saying something like, if Newton has given this law, that gravity law, I mean, how did he prove that one? We have to go through the process. Did he prove that one experimentally? If he has satisfactorily proved that scientifically, yes, okay, we can accept that thing. But if it was his personal imagination, it was his personal opinion, no, don't accept it till you get it confirmed. So there are multiple ways. Like for example, see if it is backed up by certain experimentation, proper experimentation, it is backed up by certain peer reviews. I'm just talking about engineering right now. If it is backed up by certain, like for example, projects which have, like for example, the data has been generated properly, you can easily judge that thing. So conference papers, if you look at conference papers are mostly opinions of persons or partially based on partial experimentation. So use that knowledge carefully. So if you want to get authentic answers, get from the authentic sources. I have given you, like for example, some idea about how to get authentic sources. Okay, if a person is telling you something, this is my idea, don't get that idea. Go back, okay, ask him from where you are talking about. I mean, are you referring to a book or something published or something experimentally proven? Okay, fine. If he's expressing, no, this is based on my experience, just my experience, he has to prove that how he did he get through this process. There is always a process through which something has to pass before it becomes law. So, okay, so we have to understand this thing. But I'm just giving you a very general idea. This requires a lot of training at the grassroots levels. Human children should be, our children should be taught this thing. They should be given examples. They should be checked and see whether they believe in something which is not authentic. They should be checked from that point of view. Okay, so this is my general perception. So with time, you develop this habit, okay, or you develop this trait that you will start saying, no, this is not right and this is wrong. Okay, and more knowledge you gain about your specific field, you will gain this light to differentiate between wrong and right. Okay, so your own knowledge, own intelligence which you have gained through authentic sources, if someone tells you something which is in contradiction to all this authentic intelligence which you have gained, you will say, no, I don't believe you, even if you had high conviction. I don't believe you because this is in contradiction with the established facts. Okay, so there are certain steps, initiating steps, and there are certain experimentation steps required to develop this habit.
Thank you, Doctor, for your detailed answer. Hopefully, Khalid, your question is adequately answered.
Yeah, thank you.
Now we have a question from Suhail Kibriya. First, he has just made a comment: in attaining wisdom, self-understanding is often inadequate. The knowledge needs to be brushed up through accomplished mentors for inculcation of wisdom. Now, the question is, what type of mentors qualify as the real mentors, PhDs and postdoctorate set aside? So, Dr. Saab, what type of mentors will qualify as the real mentors?
Yeah, in fact, I have partially addressed this question in the answer to the first question. In fact, we have to choose mentors. There is no problem. Definitely, an education level and an experience level is required. But we don't have to rely on each and every statement which they tell us. This is sometimes people get annoyed with me or get allergic to my statement, but this is the fact that no one is perfect. Every one of us should understand that we are not perfect and no one else is perfect. So we choose a mentor definitely based on certain minimum qualifications and experience, but we don't have to rely on them. Whatever they are telling us, we have to confirm by ourselves. We have to confirm from other sources, other established knowledge sources, established experimented sources. Okay, so we have to make a habit that whatever we hear from people, even if it makes sense, sometimes it's not true. And sometimes if it does, so I agree with Sir Sohail Kibriya that we have to choose mentors. This is I have expressed in my my lecture also in this slide when I was talking about this slide that questions over here. We have to get this conceptual mind has to get answers from outside. Okay, which Mr. Sohail Kibriya is saying that the mentors. Okay, so we have to get from different mentors or teachers or bosses or whatever seniors we have to get answers. But if we have a well-developed conceptual mind, we will be able to filter out. We'll be able to filter out the right and the wrong over here. So we have to use multi-prompts.
Thank you, Doctor. Very well answered. I'm just pressed with the time. So next question is, how intelligent is the artificial intelligence in engineering today? Please throw some light on its limitations today and in future. Very briefly, Dr. Saab, very briefly.
Actually, Mr. Sai Sultan, you are right that that when you are saying that it's briefly, actually, I think there is a complete lecture required on it.
I think
A separate lecture is required on it.
Yeah, I realize this is a detailed question. Maybe you can't answer it in a very briefly. We go to the next question. What is real intelligence? This is again from Sohail Kibriya. What is real intelligence? Many people around us appear experts due to repetitive use of skills, and common men call them intelligent, which is not the case.
Yeah, actually, perfectly right. The problem is this, that if we have a judging mind, good judging mind, we can judge it. But if we don't have judging mind, we have a memorization center invoked only in our minds or in our brains, then we go very superficially about these examples and we accept whatever they are saying. But that shows the importance of developing our own core thinking and critical thinking skills, so that we can differentiate between these people. We can say that although it seems that he's very well reputed or very well known, or he's doing some repetitive work in the society and it's acceptable, but in fact it is not right. So in order to do it, we should have our own judging or development of our own judgment mind. So that's very important. If we don't have, definitely we'll fall in that pit. I hope the answer is clear. Mr. Sultan, your mic is mute actually.
Oh, sorry. Sorry, Ji, I was hard
please.
pressed with the time only because I have to complete this session within 2 hours. Today, I have only one source of recording. Facebook did not connect today, so I'm recording everything on Zoom. So I have to finish it within 2 hours. Khalid Bashir is asking a question. It is not a question. He is just asking that he needs the recording of this lecture. You will get it. Just contact Khalid. You have to contact Sadia, Miss Sadia, and she will give you the recording. You can contact him, contact her
Okay.
anytime at your convenience.
Thank
So
you.
with So now, with this, I have to conclude here because I have to make some announcements and closing remarks. And thank you very much, Dr. Saab, for this unique lecture. And engineers really need particularly the emerging engineers need such. This was a tonic lecture, so they need this sort of a tonic in their career. And I would just like to make one comment on the lecture, that is knowledge versus wisdom. As we get experienced, as we start pursuing our career in the field and we get experience, I think automatically wisdom starts prevailing over the knowledge as we get our hands are more experienced, and there are some gray areas in the engineering practice. There, I think, as you gain more experience, you are in a position to use your wisdom. So wisdom and knowledge must travel together with the experience you gain. So this was just a comment I wanted to make. Again, thank you very much, Khalid Bashir, your comment, excellent lecture. Now, let me make the announcement for the next lecture first. Next lecture is on 12th July 2025. The topic is pile design and construction practices, including aspects of pile integrity and dynamic loading testing. Our speaker is Amir Wasim Hassan. He's a manager construction in Saudi Arabian Bechtel company. The certificates of this lecture can be collected from 19th June onwards from our office, 14A1 Block P, Model Town Extension, Lahore. And those who want to confirm whether their certificates are ready, they can contact Ahmed Akram on 0347462511. I repeat, the contact person for the certificates is Ahmed Akram. His cell number is 0347462511. And Dr. Saab, your shield and your certificate, inshallah, will be sent to you by a special messenger at your home address. So now this brings today to the close of this program. And before I end, I want to give special thanks to my team who work in the background, and with their efforts, you get this smooth and quality broadcast. Inshallah, I will see you on 12th of July. Dr. Saab, thank you very much, and Allah bless you all.
Thank you very much, sir. Allah Hafiz.